In this video, we're going to look at the general equations of projectile motion. So here we've got our projectile, which has been launched with a velocity of u meters per second at an angle of alpha to the horizontal. It's reached a maximum height of h, and it's got a range of r, and the path that it follows is this parabola. One of the other things we can do then is split the u into its components. So the horizontal component is going to be u cos alpha, and the vertical component of u is u sine alpha. So if we think about the horizontal motion, so if we were to fill in our SUVAT information, the displacement that we're looking for is x, the initial velocity is u cos alpha, and the acceleration is 0, the velocity is, well, it's always constant, and then the time taken is t. For the vertical motion, so again, if we think of SUVAT, so s is going to be a vertical distance, so we could call it y. The initial velocity is u sine alpha, and that's taken up as positive. Final velocity, we don't really know. The acceleration that it takes is gravity, so it's going to be minus g, because we're taking up as positive, and the time taken to reach whatever point it is we're looking at is going to be t. So if we want to think about the flight time for vertical motion, and the flight time is the time that it takes to return, or it stops flying, so it returns to the ground again. In that case, s or y is going to equal 0. So if we put that into our SUVAT equations, we can use s equals ut plus a half at squared. 0 is going to equal u sine alpha times t, and then a half of g, so that's, well, minus g, so it's going to be minus g over 2 t squared. So to find the length of time then, we'll factorise out a t, and we'll have t upon u sine alpha minus g over 2t. So that means that t is going to equal 0. That's the first factor, and that makes sense because initially it's at the ground. So then the other option would be that u sine alpha minus g over 2t will equal 0. So then t is going to be 2 u sine alpha over g. So for the range then, we're going to have s equals vt. So the distance, which is the x value, that's going to equal r. So we'll get r equals v, which was u cos alpha, times by the time, which is 2 u sine alpha over g. And that simplifies to 2 u squared sine alpha cos alpha over g. And what we should notice is we've got a 2, a sine alpha cos alpha. That can be rewritten using the double angle formula, which would be sine 2 alpha. So the range then is going to be u squared sine 2 alpha over g. So generally then, if we're looking for the flight time, it's going to be 2 u sine alpha over g, and for the range, it's going to be u squared sine 2 alpha over g. Now the maximum horizontal range is reached at an angle of 45 degrees, because whenever you use 45 degrees, if alpha is 45, then 2 alpha is 90, and the sine of 90 is 1. So that gives us the maximum value of u squared over g. If any other value of alpha we used, 2 alpha is going to come in at something less or more than 90, which means that whenever you do the sine of it, it's going to be less than 1. So you're multiplying u squared over g by something less than 1, so it's going to make it smaller. So the maximum value of range will have alpha is 45, 2 alpha is 90, sine 2 alpha is going to be 1, so then the maximum is u squared over g. So again, looking back at our horizontal motion and vertical motion general formula that we worked out at the start, we can then use these for maximum height. Now at the maximum height, the vertical velocity is 0. So if we consider vertically, what we're going to have then is that v will also equal 0. So we can use v equals u plus at. So we've got 0 equals u sine alpha minus gt. So then t is going to equal u sine alpha over g. Or the other way we could have done it was previously we had said that the time taken to have the range was 2u sine alpha over g, and that was for the full range. So for the max height, it would be t over 2, which is going to be u sine alpha over g. So this is looking at what we did previously there, just on range, but this is just doing it in terms of the vertical. So this is the up and down, or this is the up and down, and then this would be half of it, which is what we've just worked out. So then this t is the length of time that it takes to reach the top. Now to work out the actual height, then again, using our vertical motion equation then for s, we have that s equals ut plus a half at squared. S, this time we're looking for h, the height. So h is going to equal u sine alpha times t. Now the time taken was u sine alpha over g. So we're going to go u sine alpha over g plus a half times a, which is minus g, times t squared. So that's u sine alpha over g squared. Now tidying this up, the first term will be u squared sine squared alpha over g, and then one of the g's will cancel with the minus g. So because we've got squared, it's going to be g squared, but that'll cancel with the minus g to be just over g, and we'll have minus, so the plus and the minus gives a minus, and we're going to have u squared sine squared alpha over 2g. Now we've got a fraction minus another fraction. We need a common denominator. So that's going to be 2u squared sine squared alpha over 2g minus u squared sine squared alpha over 2g, which is going to be u squared sine squared alpha over 2g. So the maximum height, generally speaking, the maximum height of a particle is going to be u squared sine squared alpha over 2g. Moving on to the equation of trajectory. So the motion of the particle from O to the point P xy. So there's the origin and there's the point xy, and it could be anywhere along this path. It doesn't matter, I've just picked here just for any point, but it equally could have been the left-hand side of the maximum height. So if we consider the horizontal motion equations, obviously what we've got is it'll be a projected velocity of u at alpha to the horizontal. So the horizontal motion will be u cos alpha. The displacement travelled is x, it's the x coordinate. The time taken to reach there will be t seconds, and because it's horizontal motion, there's no acceleration. For the vertical motion then, u, the initial velocity, is the vertical component of u, so it's u sine alpha, and that's moving up the way. So depending on which way we take as positive or negative, will determine its sign, but it's u sine alpha going up. The distance travelled in the y direction is obviously y for this point. The time taken to get there is t seconds again, and the acceleration, which is acting, it's either acting down, in which case it's g, or it would be minus g if we're taking up as positive. So for vertical motion then, what we have is s equals ut plus a half at squared. So substituting in what we've got, we have that y equals u sine alpha t minus a half g t squared. And we're going to call that equation 1. For horizontal motion, what we have is s equals vt. So s is x, and vt is u cos alpha t. And that's going to be our second equation. So what we're really looking at for the equation of trajectory is an equation connecting y and x and alpha. So those are the three things that will be dependent on each other, will be x, y, alpha and u. So the first thing then that we can do is we can manipulate equation 2 for t, and t will equal x over u cos alpha. And we can substitute that in to 1, where we'll have y equals u sine alpha t, but t is x over u cos alpha, minus a half g times x over u cos alpha squared. Now what we'll see is that the u and the u will cancel, and the sine alpha and the cos alpha give tan alpha. So we get y equals x tan alpha. And then minus, so we're going to have gx squared over 2u squared cos squared alpha. So now what we've got is, we can see we've got an over cos squared. Now 1 over cos squared is sec squared. So we can rewrite this as y equals x tan alpha minus gx squared sec squared alpha over 2u squared. From our quadratic trig identities, we know that sine squared alpha plus cos squared alpha equals 1, and dividing through by cos squared, we have tan squared alpha plus 1 equals sec squared alpha. So what we can do is we can replace sec squared alpha, and what we'll have is an expression all in terms of tan. So we have y equals x tan alpha minus gx squared upon 1 plus tan squared alpha over 2u squared. Now this is an examinable proof, so you should learn this. And what we've got is 4 variables are x, y, u and alpha. And if 3 are known, then the 4th can be worked out.